Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the difference between rational and irrational numbers. So most of the numbers that you know are rational numbers. Rational numbers includes all integers, fractions, terminating and recurring decimals. So for example, 3 is rational because it's a whole number. Any fraction with integers like 5/8, that is rational. And we know that fractions always have either a terminating or recurring decimal. So that means they must also be rational. 5/8 is the same as 0.625. They're literally the same number. So 0.625 is rational. It's a terminating decimal. Any recurring decimal, let's say 0.4 recurring, that will be rational. So you're probably thinking to yourself, well, hang on a minute. If rational includes all terminating and recurring decimals, how can we have irrational numbers? How is that possible? What could you have other than a terminating or recurring decimals? Well, irrational numbers are numbers that are just not rational. They don't have a terminating decimal, they don't have a recurring decimal. So remember, terminating decimals end, recurring decimals go forever, but there has to be a pattern to it. So irrational numbers, their decimal goes forever, but there's no pattern to it. So an example of an irrational number is the square root of 2. Its decimal is 1.41421356. It goes forever and ever, but there is no pattern. You can't tell which number will be at any given decimal place. So square root of 2 is irrational. In fact, if you square root a non-perfect square, you always get an irrational number. So just to jog your memory, let's go through perfect squares. So perfect squares are numbers you get when you multiply an integer, a whole number, by itself. So 0 times 0 is 0. 0 is a perfect square. 1 times 1 is 1. 2 times 2 is 4. So 4 is a perfect square. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, and so on. So what do perfect squares have to do with rational and irrational numbers? Well, if you square root a perfect square, any of these numbers, you get an integer. So they're rational. So 9, for example, is a perfect square. So the square root of 9 is rational. In fact, the square root of 9 is just 3. And 3 is rational because it's an integer. So when you square root a perfect square, you get an integer and therefore a rational number. But if you square root a non-perfect square, you get an irrational number. So notice, for example, on this list, 20 is not included. 20 is not a perfect square. You can't multiply an integer by itself to get 20. So 20 is a non-perfect square. That means the square root of 20 is an irrational number. It has a decimal that doesn't end, it goes forever, but there is no pattern towards it. Another example, say you see on that list 24 is not listed. 24 is not a perfect square, so the square root of 24 is irrational. We can tell before putting it on our calculator that the square root of 24 will have a decimal that goes forever, but there is no pattern. So just to make this distinction clear, all integers are rational numbers. So 20 by itself is rational, but the square root of 20 is irrational. 24 is rational, but the square root of 24 is irrational because 24 is not a perfect square. So if you square root a perfect square like 9, it's rational. If you square root a non-perfect square like 20 or 24, then the number is irrational. So other examples of irrational numbers, a lot of people know pi. It's okay if you don't. Pi is the number 3.141592653, blah, blah, blah. It goes on forever. Its decimal goes forever, but there is no pattern. Pi you'll see a lot when you do area and circumference of circles. So pi is irrational. And there are heaps more irrational numbers. It turns out if you add a rational number and an irrational number, you get an irrational number. So pi is irrational, pi plus 1 is irrational, pi plus 2 is irrational, and so on. So most of the numbers you know are rational. Anything that's an integer or a fraction, anything that can be written as either a terminating decimal or a recurring decimal is rational. All of these are rational. Irrational numbers are just not rational. Their decimals go on forever and ever, but there is no pattern. Their decimal is neither terminating nor recurring. So to find some examples of an irrational number, if you square root any non-perfect square, you will have an irrational number. Pi is also irrational, as is pi plus any number you can think of. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.